Okay, so today we're going to talk about Cavalieri's principle. The standards we're going to talk about is just to see how did we come up with these volume formulas that we dealt with yesterday, and what does Cavalieri's principle say about the volumes of two figures, or two 3D figures. So let me go back and explain. So Cavalieri's principle tells us, and let me show you. So if you think about a cylinder looks like this, and then you're going to have some height, which is the dotted part, and then you're going to have your circular part at the top. That's a cylinder. So what Cavalieri's principle tells us is that this cylinder is actually just a bunch of these bases, circular bases, on top of each other. That's all it's saying. And so what he says, when you come up with that formula, then that is why you can do the area of the base multiplied by the height. So the area of the base would be a circle, and honestly what you can do is say how many times is this circular piece being stacked up to the top. So that's why it says to just multiply by the height. Okay, that's what Cavalieri's principle means. Now, another part of this principle is that if I have two objects, let's see, if I have a cylinder and a cone, all right, so what this means, that if I have a cylinder and I pour something in it, and then I have so let's say we poured something in here, and then I have a cone and I pour something in it, then Cavalieri's principle tells me that if the area of the two bases are the same, and if you turn the cone upside down, that would be the base. If the area of the two bases are the same, and the height of the two objects are the same, and the height is the same, then the two figures will have the same volume. That is Cavalieri's principle. So they're going to hold the same amount. So as long as the bases are the same, the area of the bases are the same, and they go up to the same height, then you're in the game. They're going to hold the same amount. That's the basis of that principle. All right, so here in this first picture, it says a cylinder A and cylinder B are shown below. What is the volume of each cylinder? What conclusion can you make? So the volume of a cylinder, if you look at your formula sheet, is the area of the base, which is pi r squared, multiplied by the height. So I'm going to find the volume of cylinder A. Radius is 5 because the diameter was 10 and the height is 12. This is volume A. And so I would get that is 60 pi. And now I'm going to do the volume for cylinder B, which is going to be the same formula. And I need to be careful, make sure I get the base. The radius is not 10, it's 5. Oh, I messed up. I'll go back to the other one in a second. Times 12. So the volume of this is equal to 25 times 12. So let me graph that. (300 pi). And here I forgot the square, so let's go back and fix that. And we just did it for the other one. So that's 300 pi. And if you notice, the volume of these two figures are the same. They're exactly the same. Even though the other one is slanted some, it's still the same. And that is because of Cavalieri's principle. It tells us no matter what happens, as long as the area of the base of the two figures are the same and they have the same height, it doesn't matter what you do to them. You can bend them up, turn them around, flip them over, whatever. The two volumes will be the same. So we can say our conclusion is the two volumes are the same. And that is because the area of the bases are the same, and they have the same height. And there we go. So that's the answer to that question. Now this next question says, what is the volume of the cone shown below? All right, so the volume of a cone is equal to 1/3 of pi r squared times the height. And this is on your formula sheet. So if we look here, we know the radius is 8, but we have a problem. And they tricked us in this one, so you need to be very, very careful. This is what we call the slanted height. This highlighted part that I'm going to give you is called the slanted height. You cannot use that to substitute in for height. But now you have to do some thinking. You need to find this dotted line that's in the middle. And you know something. That is a right triangle. So in order to find the height, so we're going to say that is this height here is one of the legs. So we're going to say H, which we can call A or B. I'm going to call this B. And I'm going to call this C because that is across from the right angle. So that's the hypotenuse. So in order to find H, we need to do Pythagorean Theorem. So A squared, which we don't know. So we're going to just say H squared plus 8 squared should equal 17 squared. All right. So now we're dealing with H squared plus 64 equals, let's see, 17 squared, 289. All right, and then we solve this, so subtract 64. And how we solve equations, variables on the left side, constants are on the right side. $225. So in order to undo something squared, you have to take the square root. So square root of 225. So here's square root of 225 equals 15. So H equals 15. So now we need to do the math here. So now I know the height is equal to 15. Now I can substitute into the formula and I'm in the game. So be very, very careful. So volume in this case equals, now let me put a dotted line between these two sides. So to separate them. Oops. All right, just so you can see the separation between these two problems. So volume is Volume is 1/3 pi, and the r is 8, so 8 squared times 15. And go and use your calculator to knock that out. So you get alpha y equals, we're going to put in that 1/3, 1/3 times 8 raised to the second power times 15. Oops, get out the air. $320. So the volume here equals 320 pi. And let's see if we have any units. Yes, we do. So this is going to be centimeters cubed. Okay. So that's the answer for that question. So just please, 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 dear babies, be careful with that slanted height. And that's one of those common mistakes that students make. So I'm trying to head you off before you make it. Okay, let me give some space in between these two sides. So we can do the next problem. Okay, so the next problem, it says a cylinder has a radius of 10 centimeters and a height of 9 centimeters, and a cone has a radius of 10 centimeters and a height of 9 centimeters. Show that the volume of a cone is 3 times the show that the volume of a cylinder is 3 times the volume of a cone. So if we go here, this is the part we need the answer. So as we've been practicing in class, put this in your own words. So you want to find out, how can I show that a volume of a cylinder, well, the cylinder has 3 times the volume that a cone has. That's what we're trying to find out. So the next part of things we've been doing in class during our opening says, now go and identify what's given. So here it says the cylinder has a radius of 10 and a height of 9 centimeters. And a cone has a radius of 10 and a height of 9 centimeters. So now I need to find out, how do I use this information to answer the question that I already know I need to try to say, okay, the cylinder is has 3 times as much volume as the cone has. So what I'm going to do, well, I know I'm dealing with 2 formulas. This is my plan. So my volume for the for the cylinder will be pi r squared times the height. And my volume for the cone would be 1/3 of pi r squared times the height. So I'm going to work with each information here and make it do what it do. So volume equals pi, volume for that cylinder. The radius is 10, so I'm safe to just put that in. And the height is 9. So I'm going to go and pull my calculator up. Help me with that math. And the calculator is a good skill to use, or a good tool to use to double check your mental math too. So this is 900. So 900 pi. And then if I do the volume of the cylinder next, so I'm going to do 1/3 of pi times the radius is 9. Is it 9? No, it's 10. The radius is 10 times 9. So here we're going to go to our calculator and we're going to say alpha y equals 1/3, and we're going to say 10 squared times 9, and that's 300. And that's 300 pi. So the question said, show that this is the volume of the cylinder is 3 times the volume of the cone. Well, watch this. This is 900. And then this is the volume of the cone right here. If you take these 2 volumes and divide them, then you will see that if I take the volume of the cylinder, so this is the volume of the cylinder, and put it over the volume of the cone, you can see that this is going to end up as 3. So the volume of the cone to the volume of the cylinder, the volume of the cylinder to the volume of the cone is 3/1. So that means if I take this one down here and multiply it by 3, I'm going to get this one. And if I take this one up here and divide it by 3, then I'm going to get this one. So that's all that means. So we compared those two. So what I want you to do is to go through and complete the rest of the problems, and I will see you guys on tomorrow.